NASA confirms that Voyager 1 was the first human-made object to escape the sun's influence and cross into the cold, dark expanse of interstellar space. But this isn't just another spacecraft. It is more like a ghost whispering faint signals from the silence of the cosmos. Launched in 1977 for what was expected to be a 5-year mission, Voyager 1 now drifts nearly 14 billion miles from Earth, still active after almost half a century. It has gone farther than any other creation of humankind, venturing into a region no machine had ever reached before. Despite carrying less computing power than a digital wristwatch and storage smaller than a single image on your phone, it continues to transmit messages from beyond the solar system. Instead of answers, Voyager often leaves us with deeper mysteries. And recently, it has surprised scientists yet again by revealing something no one anticipated. The mission itself was born out of a rare cosmic opportunity. In the early 1970s, astronomers discovered that once every 176 years, the outer planets, Jupiter, Saturn, Uranus, and Neptune, align in a way that allows a spacecraft to slingshot from one to the next, gaining speed without using much fuel. Engineer Gary Flandreau at NASA's Jet Propulsion Laboratory noticed this planetary highway with nothing more than paper, pencil, and calculations. Instead of taking decades of propulsion, a probe could reach Neptune in only 12 years. The timing was critical. The alignment would peak in the late 1970s, and missing it meant waiting another lifetime. NASA acted quickly, launching 2 spacecraft just weeks apart in 1977, Voyager 1 and Voyager 2. At first, their goal was modest: study Jupiter and Saturn up close, then shut down. But the spacecraft proved far tougher than expected. They endured radiation belts, freezing darkness, and countless hazards. Alongside scientific instruments, each carried a golden record: images of life on Earth, greetings in dozens of languages, music from around the world, and sounds of nature, a time capsule cast into the ocean of stars. The discoveries began almost immediately. When Voyager 1 reached Jupiter in 1979, it sent back astonishing images. The gas giant was not a still, lifeless world, but a planet alive with storms and violent activity. Its moon Io stunned scientists with erupting volcanoes, the first ever seen beyond Earth. A year later, Voyager 1 captured Saturn's dazzling rings and turned its cameras toward Titan, a world hidden beneath a thick orange haze with signs of a complex atmosphere, perhaps even ingredients for life. Voyager 2 later continued to Uranus and Neptune, becoming the only spacecraft to fly by those distant worlds. Meanwhile, Voyager 1 pressed outward into the dark, leaving its cameras behind to conserve power but keeping its instruments running. What made these encounters even more remarkable was the technology. With only 69 kilobytes of memory and tape recorders for data, Voyager's brain was far weaker than today's simplest devices. Yet it navigated asteroid fields, magnetic storms, and frozen moons flawlessly. Each planet it passed transformed our view of the solar system. But its greatest revelation came much later. Decades beyond Neptune, Voyager 1 approached the mysterious boundary where the sun's influence ends, the heliopause. Scientists long debated where exactly this invisible frontier lay, where the solar wind gives way to the interstellar medium. On August 25, 2012, Voyager 1 crossed that line. Its instruments detected fewer solar particles and more high-energy cosmic rays from ancient supernovae. Humanity had officially entered interstellar space. Yet something was strange. The direction of the magnetic field did not shift as expected, raising new questions. Had Voyager entered a transition zone, a turbulent sea where solar and galactic forces mix? The boundary, it seemed, was far more complex than a simple line. Even more mysterious, the probe soon detected bizarre plasma fluctuations. Instead of a calm, uniform environment, the interstellar medium was textured with sudden rises and drops in density, as though Voyager were drifting through clouds left behind by exploded stars. These may be remnants of long-dead supernovae, cosmic fossils millions of years old. Voyager was not just traveling through space, but also through history, brushing against the ghostly fingerprints of ancient stars. Despite the harshness, Voyager still carries a message from us. Fastened to its side is the golden record, designed to last billions of years. Greetings in 55 languages, sounds of nature, laughter, music, and even the beating heart of a young woman. Carl Sagan, who led the project, called it a gesture of hope, a way to say this is who we are to any civilization that might one day encounter it. Now more than 22 billion kilometers from Earth, its weak signals take over 20 hours to reach us. One by one, instruments are being shut down to conserve its dwindling power. Sometime in the next few years, Voyager 1 will fall silent. Yet even without energy, it will continue drifting through the galaxy for billions of years, perhaps passing unknown stars, perhaps never to be found. But its mission has already succeeded. It extended human imagination far beyond the horizon. Voyager 1 began as a scientific project, but became something deeper. A reminder that curiosity and persistence can outlast generations. It carries no flag, no claim of conquest. Only questions and a voice that whispers across the dark. We were here and we dared to explore. Even when it stops transmitting, its journey will never truly end. For as long as it sails among the stars, Voyager will remain a mirror of ourselves, fragile, determined, and endlessly curious. And so the question lingers, if this tiny spacecraft built with 1970s technology can travel so far into the unknown, what else might we one day achieve?